This is problem number 5 from the Wastewater Collection Math SewerGeek.com book. This problem states that if rain falls for 2 hours on a parking lot that is 205 feet by 185 feet, the amount of rain that fell was measured at 2.5 inches. Calculate the flow in GPM. Well, first thing I'm going to do is simplify this problem before I do anything else. I'm going to make things a little more obvious. GPM is gallons per minute. So I'm going to cross this stuff out and it's just write gallons per minute. And the reason I do that is because in the formula, in the problem, a lot of times they give you the formula. And there it is right now. Figure out how many gallons by how many minutes and divide it. It's that simple. And then we're going to convert to units that we can use. We're going to convert into feet. I mean, we can't convert into gallons yet, so we're going to convert into feet first. 2.5 inches. And I'm going to take 2.5 inches and divide it by 12. And that's going to give me 0.208 feet. So I'm going to cross that out and go 0.208 feet. And then it's in minutes, so I'm going to take 2 hours, get rid of that, and that's going to be 120 minutes. It's 60 minutes in an hour. And so that's going to make it relatively simple. Then I'm going to figure out the area of the parking lot. And it's going to be a square parking lot because it says 205 by 185. And plus they don't normally make parking lots round. So area equals 205, nice going, feet by 185 feet. It's going to be about 4,000, a little less, 3,800, because 200 times 200 would be 4,000. It's a little less. So let's go 205 times 185. And I think it's important to guesstimate like that, so when you fat finger the calculator, you notice it. So it's not quite 3,800, 3,792. 3,790. Yep, that's wrong. 37,925. 40,000, not 400,000. So there we go. 37,925 feet squared. And we need the volume, so we need a depth. So I'm going to go, because it's length times width times height, I'm going to draw my parking lot. It's a big square parking lot, and it's going to be 205 by 185 feet, and then I'm going to have a depth. And it's not going to be much, it's going to be 0.208. So I really should have taken that 205 times 185 and gone times 0.208 feet to give me feet cubed. I can come down here and go times 0.208 feet, and that'll give me square feet times 0.208 feet, and that'll give me the volume. So I'm going to go 37,925 times 0.208, and that's going to give me 7,888.4. 888.4 feet cubed. There's a conversion to go from cubic feet to gallons, and that's going to be each 1 foot cubed equals 7.48 gallons, and that's in the book at SewerGeek. All the variables or formulas and the constants that you're going to need in conversions, they're all in there, and it's all like in the second or third page, so you can read that. I'm not going to explain them all every time. So what I'm going to do is, if 1 cubic foot equals 7.48 gallons, and 7,000 cubic foot will equal, well, a lot. So I'm going to go times 7.48 gallons per foot cubed. This will cancel out, and I'm going to end up with gallons. And it's going to be 7,000 times 7. It's going to be like 60, 70,000. So let's go times 7.48. And it's going to give me 5 59,005.2 gallons. Close enough. 59,005.2 gallons. So there's my formula, gallons per minute. So I'm going to need minutes. So now where's the minutes? 120. So I'm going to divide it by 120. 59,005 divided by 120 minutes. And I'm going to get 4917. 491. I put a decimal point with my marker. 491.7 gallons per minute. And that's going to be 492 gallons per minute. So the answer is going to be D.